Today, let's go over a medium question that is in the tree category that I just solved by myself. Surprisingly, because I struggled with this for a long time and I just couldn't get anything to work. But I guess I took a break from it for like a month, and then today I came back to it, and for some reason I was miraculously able to solve it. So it's kind of strange how things work. So let's read it. So you're given the root of a binary tree, and essentially what it asks you to do is replace the value of each node in the tree with the sum of its cousins' values. And I think that's where I misunderstood a little bit. So what sum of cousins' values actually means, if you look at the diagram here, it pretty much tells you everything. But if you have like more levels, it doesn't really tell you much. So fill the 0th and the first level, like zero indexing with zeros. And then for every level beyond that, you get the sum of the level, and then minus, and the position of the children's nodes are supposed to be the sum of the whole level minus the current children's nodes. So for example, this level has the sum of 1 plus 10 plus 7 is 18. So then the left child is supposed to have sum of 11, because the right child has a sum of 7. 18 minus 7 is 11. And then the left child is supposed to be, let's put this as right child. 18 minus 11 is 7. Left child, because the right child or the left child has a sum of 11. So the total level sum minus the sum of the right child's, the opposite child's, or everything not including this current child's sum is equal to the current sum. So for example, again here, this would be 11, because 18 minus 11, which is the sum of this is the opposite of this, is 7. And the sum of this is supposed to be 7, because 18 minus 11 is supposed to be 7. So it's kind of confusing, but let's look at some more examples here. This doesn't really tell you much, because the first and second levels are supposed to be all zeros. But I think if you don't have a left or right child here, it still makes sense to make it the value itself. So just think the whole level sum minus the current level sum, or the current children's sum for each node. So because this is 11, because the total children's sum here, actually, you know what? I think I got it backwards. Excuse me. Whole level sum is 18 minus the current sum is the current sum. It's not the opposite. So it's just level sum 18 minus 11 is 7. So they're both 7. Level sum 18 minus 7 is 11. So is 11. So just think the same child sum minus the whole level sum. And first, before we do anything, we want to build a list. So basically we want to pre-calculate all the level sums, and this is a mistake I made originally, because if you don't do that, then you're going to mess up the levels as you're traversing through the tree. We're going to traverse through the tree twice. So let's do a standard level order traversal here to get all the level values. And then this is just standard level order. So this is the node we're popping from the front of the queue, and then checking that it's not none to make sure it has a value. And then now we can say level.append current.value, because it actually has a value attribute. It's not none. Append the left child, which is 4. Append the right child, which is 9. And then now if the level exists, then we can just append the sum of the level. We're just, again, getting the sum of 5, and then 13, and then 18. Let's print the result. 5, 13, 18. Now let's do another level order traversal. Now we actually want to update the values according to the children's sum as we talked about. So this is supposed to be 7, because we're going to calculate this as 11, and then say the whole thing 18 minus 11 for 7 and 7. So now let's create another queue. And this time we're going to append the root, and let's think of this as 0 indexed, because our array is 0 indexed. So the first level is supposed to be 0, the second level is supposed to be 1, and the third level is supposed to be 2. Same thing, we're going to do a level order traversal, except now we don't even need a level list because we don't need to actually calculate any sum, but we still need to pop the node and ask if the node's not none. And then now we are going to actually append, first of all, we're going to append level, we're going to call this lev, right? Because we're, what is it called? Assigning two different values. We're unpacking the values, right? And then level plus one, because the children are always going to be one level down from the current node. And then now, this is where we need to calculate the sum of the left and the right child together. So let's call this cur sum equals 0. And if the cur dot left, then cur sum plus equals cur dot left dot value. So if it's not known that it has a value, if cur dot right, so for example, if we're on 4, we're saying 4 has a left child is 1, so add 1. 4 has a right child, that's 10, so add 10. And then now let's print the current sum and also the level. We want to see that. So the current sum now is supposed to be level plus 1, it looks like. So level 1 has a sum of 13. Level 2 has a sum of 11, 0, 1, 2. This doesn't matter because what we're going to do is actually if level plus 1 is less than length of result, because we don't want to go out of bounds, right? There is no index 3 here. Okay, cool. So now, now we actually have to update the values. So 13 and 1. This is the total. This is not the total. So I think that, first of all, we mentioned that the 0th and the 1st are always going to be 0. So let's say if and level is bigger than or equal to 2, then we're going to do that. Plus 1 is bigger than or equal to 2. Okay, so now those are the ones we care about. Well, actually, let's include that check here. So if level doesn't change here. So if level plus 1 is less than, if level plus 1 is bigger than or equal to 2, then we care about doing the current sum, because otherwise we don't even care. So also at the same time, if level plus 1 is less than the length of results, then we care about this. And now you can say if the current dot left exists, then current dot left dot value is equal to result of level plus 1, because we're looking at this guy for 18 minus 11 is 7 for the left child, right? So result level minus 1 minus the current sum, right? Because the current sum is encompassing the left and the right child for this node. We're not looking at this node. We're only looking at 4 now. Current dot right, I think same thing. Current dot right dot value is equal to result level plus 1 minus current sum. And then otherwise, if level is less than or equal to 1, then current dot value is just 0. We can just set that current node to 0. This should be right, and at the end we can just return the root node because we're modifying the tree as we do the level order traversal. Okay. So here still have some issues because looks like we didn't actually do the first level. So if level is actually equal to 1, then current dot value is 0. And let's say elif. No, let's see here. Level plus 1 is bigger than or equal to 2. Maybe we can do it like that. So let's do it after, because that's only what matters. We still need to do this. So if level is less than or equal to 1, then okay. So, okay. In this case, trying to think here. The level is, if current, then let's just this still has to be reset. That's the problem. So if level is equal to 1, cur.value is 0. Or level is equal to 0. Okay, yeah, there we go. Because again, we do the modification, we add the sum, and then the sum might have to be overridden by the 0 as the last case. So yep, there you go. So it's not too complicated, but there are some edge cases there. And again, just looking at the diagram really helps. So I hope this made sense. Again, here we're just modifying the tree values itself as we go over level by level, while the purpose of this was just to get the sum of each level in the tree. So if you found this helpful, consider subscribing and stay tuned for more. Thank you for watching.